Today, we've got some mind-blowing news from the cosmos. The James Webb Space Telescope has captured what seems to be an incredible snapshot of a massive collision of giant asteroids in the Beta Pictoris star system. Beta Pictoris is known for its early age and chaotic planet-forming activity, making this discovery even more fascinating. Astronomers have long been intrigued by the volatile processes that shape star systems, and now, thanks to Webb's detailed observations, we're getting a unique glimpse into the primordial stages of planetary formation. According to Christine Chen, the lead researcher from Johns Hopkins University, Beta Pictoris is at an age when planet formation in the terrestrial planet zone is still ongoing through giant asteroid collisions. What we could be seeing here is basically how rocky planets and other bodies are forming in real time. Chen's team noticed significant changes in the energy signatures emitted by dust grains around Beta Pictoris. They compared new data from the James Webb Space Telescope with observations made by the Spitzer Space Telescope in 2004 and 2005. Webb's detailed measurements allowed the team to track the composition and size of the dust particles in the exact area previously analyzed by Spitzer. By focusing on the heat emitted by crystalline silicates, minerals commonly found around young stars and on Earth, the scientists discovered that the particles seen in 2004-05 were no longer present. This indicates that a catastrophic collision among asteroids and other objects occurred about 20 years ago, reducing them to fine dust particles smaller than pollen or powdered sugar. Chen explains, "We think all that dust is what we initially saw in the Spitzer data from 2004 and 2005. With Webb's new data, the best explanation we have is that we witnessed the aftermath of a rare, cataclysmic event between large asteroid-sized bodies, completely changing our understanding of this star system. The new data suggests that dust previously dispersed by radiation from the system's central star is no longer detectable. Initially, this dust heated up and emitted thermal radiation that Spitzer's instruments identified. Now, as the dust has moved far away from the star and cooled, it no longer emits those thermal features. When Spitzer collected the earlier data, scientists assumed that small bodies grinding down would steadily replenish the dust over time. However, Webb's new observations show that the dust has disappeared and was not replaced. The amount of dust kicked up is estimated to be about 100,000 times the size of the asteroid that caused the extinction of the dinosaurs. Beta Pictoris, located about 63 light-years from Earth, has been a focal point for astronomers because of its proximity and the random processes that will dictate the system's fate, including collisions and space weathering. At only 20 million years old, compared to our 4.5 billion-year-old solar system, Beta Pictoris is at a critical age where giant planets have formed, but terrestrial planets might still be developing. It has at least two known gas giants, Beta Pic B and C, which also influence the surrounding dust and debris. Co-author Caden Worthen, a doctoral student in astrophysics at Johns Hopkins, adds, "We're trying to understand whether the process of terrestrial and giant planet formation is common or rare, and the more basic question, are planetary systems like the solar system that rare? We're essentially trying to determine how unique or average we are." These new insights also highlight the unmatched capabilities of the Webb telescope in unveiling the intricacies of exoplanets and star systems. The findings provide key clues into how the architectures of other solar systems resemble ours and deepen our understanding of how early turmoil influences planets' atmospheres, water content, and other aspects of habitability. Co-author Cicero Liu, a former Johns Hopkins doctoral student in astrophysics, notes, "Most discoveries by JWST come from things the telescope has detected directly. In this case, our results come from what JWST did not see." The team includes experts from Johns Hopkins University, the Space Telescope Science Institute, the Johns Hopkins University Applied Physics Laboratory, the University of Rochester, the European Southern Observatory, the European Space Agency, and NASA Goddard Space Flight Center. Don't forget to subscribe to our channel and hit the notification bell to stay updated on the latest discoveries from the world of astronomy. See you in the next video. See you in